For Module 7, Lesson 8, we're going to be moving on to writing and solving two-step inequalities, which is going to be very, very similar to writing and solving two-step equations. In fact, the only difference between them is, of course, how you graph them, but more importantly, if you have to multiply or divide both sides by a negative, the sign changes directions. Other than that, you work them exactly like you would a two-step equation. There's no difference to it. Quit stressing over this stuff. According to our pacing guide, this is going to be a one-day lesson. Maybe we can even knock it out with one video. We're just going to have to see how it goes. A two-step inequality is defined as an equality that contains two different operations. Now, just like the equations, it could be addition and multiplication, subtraction and division, subtraction and multiplication, or addition and division. What it cannot be is multiplication and division or addition and subtraction. Those are still considered to be one-step inequalities. Let's watch the video on how to work these.
A two-step inequality contains two operations. To solve a two-step inequality, first undo the addition or subtraction. In this example, undo the addition by subtracting 6 from each side of the inequality. Next, undo the multiplication or division. In this example, undo the multiplication by dividing each side of the inequality by -2.
Now I want to stop and point out, they divided both sides by -2, and because of that, their sign changed direction.
If you multiply or divide each side by a negative number, remember to reverse the inequality symbol. The solution of the inequality is x is less than or equal to -3. Finally, check the solution. Start with the original inequality. Replace the variable with the number in the solution set. Then simplify to check whether the sentence is true. If so, this provides evidence that the solution is correct.
Now, once again, they said it provides evidence that the solution is correct. It's not a guarantee. It's not like an equation where you know for sure the solution is correct when you check it. But it gives you a general idea, or tells you if it's wrong. If you know it's wrong, you need to go back and look at it. But if it suggests it's right, you're probably going to be okay. Our first problem involves the inequality -5x minus 12 is less than or equal to 8. And we're going to treat it, as I've said before, just like you would treat an equation. We're going to start off by undoing addition subtraction, which means you're going to add 12 to both sides of the equal sign. That is, of course, after writing the problem down. The 12s on the left-hand side are going to zero each other out, and on the right, 8 plus 12, that gave us 20. Now we're going to undo multiplication and division by dividing -5 on both sides. And it's important to notice that we are dividing both sides by a negative. That means the sign is going to change directions just like you see right there. When you do that, the -5s on the left divide each other out, and on the right, a positive 20 divided by a -5 gave us a -4, and you can put that -4 right here if it makes you happy, and it's going to tell you you have it right. Of course, we also have to be able to graph that solution set. So to graph it, we're looking for all values that are greater than or equal to -4. So let's make it a little smaller here. So I'm going to start at -4 and go to the greater than or equal to side, check, and the answer checks. That's all there is to solving these problems. Now it's going to be your turn. Work extra example number 1 on your own on a sheet of paper. Check your answer and graph it to make sure everything's good. All right, my problem is positive 7x minus 2 is greater than or equal to 16. We're going to start solving it by undoing addition and subtraction, which means we're going to have to take and add 2 to both sides. So I'm going to do plus 2 on the left. I'm going to do plus 2 on the right. The 2's on the left zero each other out, leaving 7x is greater than or equal to, and a -16 plus 2, that's the signs are different. Find the difference problem with a sign in front of your larger number going in front of your answer. Now we're going to undo multiplication and division by dividing a positive 7 on both sides. Because I'm dividing a positive 7, my sign does not change directions. Yes, I know there's a negative 14 right there, but I just really don't care right now because it has no bearing on whether or not the sign flips. The sign only flips if you multiply or divide both sides by a negative number. These here divide out becoming 1. 1 times x is x. 14 divided by 7 is 2, and a negative divided by positive is a negative 2. So my answer is going to be x is greater than or equal to a negative 2. Come back over here. That's going to be this one right here. Check it, and it checks. And then to graph it, it's a greater than or equal to. So we're going to start with a solid circle. It goes to the right-hand side, and the answer checks. That is showing your work. That is what I must see. But what if we had a problem like this one that involved decimals? Work it the same way. I mean, really, just work it the same way. Not a big deal. So we're going to start off by undoing addition subtraction. That means that we're going to take and add 3 and 25/100ths to both sides. The 3 and 25/100ths on the left, they're going to zero each other out, leaving 4 and 7/10 x. And on the right-hand side, let's see if I can do this in my head. That's going to become 11. That's going to become 12.15. Did I do that right in my head? No, I didn't. All right, let's actually do some scratch work here. So I got 10.85 plus 3.25. So that's going to be 10.85 plus 3.25, add those up, that becomes a 9, 10, 11, decimal comes down, that goes over here, oh, that's going to become a 14.10, I think I said 14 point, not a 12.15, boy, I really missed it, didn't I? 14.10, check, and they probably wanted just 14.1, yeah, that's fine, that works too. Now we're going to undo multiplication and division by dividing the 4.7 on both sides. That's going to really take some grunt work. 14.1 divided by 4.7. I'm going to take 14.1. The first number goes to the house. The 4.7 is outside the house. Bounce a decimal outside the house until you hit the wall. Bounce a decimal inside the house the same number of places to the right, and the decimal goes up. From here, we're going to take 47 and say, how many times is 47 going to 141? And I think that answer is going to be 3. 3 times 7 is 21. 3 times 4 is 12. Plus 2 is 14. And therefore, the 3 it is. So I can come back over here now. The 4.7 is on the left divided out, leaving x is less than or equal to 3. And that answer checks. From here, of course, we still need to graph it. So on your graph, we're going to zoom out a little bit. We're less than or equal to 3. It's or equal to, so it gets a solid circle. The less than side goes to the left, and it checks. Easy math. Anybody can do this stuff. And now it's going to be your turn to solve a decimal problem on your own. Show all the steps. Pay attention to the fact you're going to be dividing both sides by a negative number. Get busy. Check your answers. Well, let's see what I'm going to do. First thing I'm going to do is undo addition subtraction by subtracting 5.6 from both sides. And that means it's going to be 5.60 right here on the right. When I do that, the 5.6 is 0 out, leave me with a negative 3.62x is less than, and I've got a situation where my signs are the same, find the sum. So I'm actually adding these, which is going to give me a negative 9.05. Now I'm going to undo multiplication and division by dividing both sides by that negative 3.62. When I do that, these divide out, becoming 1. 1 times x is x. Very important, that sign is going to change directions. It changed directions because I divided both sides by the same negative number there. After that, we're going to have to do some serious grunt work. 9.05 is the first number. It goes in the house. 3.62 is outside the house. We're going to bounce the decimal 1, 2 spaces to the right till it hits the wall. Do the same thing inside the house, and the decimal goes up. Next, we got to figure out how many times is 362 going to go into 905. and I'm going to say it's going to be 2. 3 would be too many. It's going to be 2. So 2 is my starting point. 2 times 2 is 4. 2 times 6, that's going to end up being 12. And then 2 times 3 is 6 plus 1 is going to be 7. I'm going to subtract that out. I'm going to have a 1. I'm going to do some borrowing here. 10 minus 2 is 8. And then 8 minus 7 is 1. So I've got 181, which I'm going to have to annex in the 0 and bring it down. Now I'm going to say how many times does 362 go into that? I'm going to say, well, 6 would be too many. I'm going to say 5. Plug a 5 in right here. 5 times 2 is going to be 10. 5 times 6 is going to be 30. Plus 1 is going to be 31. 5 times 3 is going to be 15. Plus a 3 from the 31 is going to give me 18. And when you look at that, I have an answer now that x is going to be a value greater than 2.5. Jump back over to my answer sheet. It's going to be greater than 2.5, and that checks. And then, of course, we still need to graph it. It's an open circle because it's not an or equal to. It's going to the right-hand side, and there it is. It checks proper. That is showing your work, folks. That is what I must see. I've got both my algebraic work, my big kid math, and I've got my grunt work, my little kid math, all mixed in there together. Example number 3, same thing, only it involves fractions. And that is one thing I really love about your textbook, is it is constantly reinforcing fractions, decimals, and percents. By the time you get done with this year, you should be rock solid on all of these. So we're going to take a look at this. It works the same exact way, undoing addition and subtraction first, which means we're going to start off by adding 4/8 to both sides. I don't like how they do fractions. Let me go ahead and do a screenshot of this. We're going to do this Mr. Reach's way because I just don't like fractions being vertical. It is just too dang confusing. So there's some good real estate. There's a nice piece of real estate right there. And we're going to start off here by adding 4/8 to both sides. So I'm going to have 3/4 x minus 4/8, and then I'm going to do plus 4/8 is going to be greater than 3/8 and then plus 4/8. Only thing that's changed, added 4/8 to both sides. Now the 4/8 on the left zeroed out, leaving 3/4 x is greater than 3/8 plus 4/8 is 7/8. Now we're going to finish isolating the variable by undoing multiplication. 3/4 is multiplying itself times x, so we're going to divide 3/4, also known as using the multiplicative inverse, multiplying by 4/3. The sign is not going to change directions because I'm multiplying with a positive number. These divided each other out, leaving x is greater than. Over here, 4 goes into 4 once, 4 goes into 8 2 times, and multiply. 7 times 1 is 7. 2 times 3 is going to be 6, which means the final answer, we got to write it as a mixed number. We can't leave it as an improper fraction. It's going to be x is greater than 1 and 1/6. Circle your answer. Let's jump back over here. And I'm going to take and follow through what they did, and I bet they're going to come up with the same thing. Yep, 1 and 1/6, same answer I got. To graph it, we're going to take and find 1 and 1/6 on the line. X is a value greater than it, but not or equal to it. Open circle, line goes to the right. Check your answer. Easy math. And it is your turn again. Solve extra example number 3. It's the last one we're going to do on part 1 of this video. Yes, we have to do this video in 2 parts. Alright, we're going to start off by undoing addition and subtraction. 1/4 is being added to the variable, so my next line is going to be x divided by 9 plus 1/4, and then I'm going to take and subtract 1/4 from both sides. I'm going to do from here less than or equal to 1/3, and then a minus 1/4 again. These just zeroed each other out, leaving x divided by 9 is less than or equal to 1/3 minus 1/4. Well, we need at least common denominator here, which is going to be 12. Something over 12 minus something over 12. 3 goes into 12 4 times. 1 times 4 is 4. 4 goes into 12 3 times. 1 times 3 is 3, which means x divided by 9 is less than or equal to 4 minus 3 is going to be 1/12. Now we're going to undo multiplication and division by multiplying both sides by 9. X is being divided by 9. We'll make that go away by multiplying 9 on both sides. 9 is a positive number, so we don't have to flip the sign, and we're going to make it 9/1 right there. Those divide out, leaving x is less than or equal to. We're going to simplify. 3 goes into 9 3 times. 3 goes into 12 4 times. And multiply to get a final answer of 3/4. That is showing your work. That is what I must see. Come back over here, and what direction was our gator? Less than or equal to? And we're going to put in a fraction of 3/4. Whoops, that didn't go over. 3/4. Accept and check. That checks. So to graph it, let's see, our value is less than or equal to, solid circle, 3/4, arrow goes to the left, and check again. Everything is good. Come back and watch part 2 where we start digging into how to write word problems into two-step equations.